Hi, my name is Camilo.
Hello, my name is Andrey,
We are bioengineering students.
and we are gonna talk about diodes. So let's start.
What is it? A diode is a two-terminal electronic component that conducts current primarily in one direction. That means an asymmetric conductance. It has low, ideally zero, resistance in one direction and high, ideally infinite resistance in the other. Here we can see an example of a diode with its anode and its cathode, and the direction at the current will flow. This characteristic explains why the diode works as a key for the passage of current, where it only allows flow when the voltage to which it is subjected creates a current from the anode to the cathode. Now, what are they made of? Diodes are made of semiconductors, materials with a crystalline structure, which in its pure state, conductivity depends on temperature. These materials are also known as the carbon family, and they are located at the group 4A on the periodic table. The most used are silicon and germanium. On the right side, we can see the effect that causes the electrons to jump from one atom to another. This is called recombination, and it is what allows the material to conduct electricity. These materials are doped in order to increase their conductivity. Some of them are doped with elements of a lower valence, such as boron, giving us an electron-free link known as a hole. These are type P materials. The other type are type N materials, which are doped with elements of a higher valence, giving us a free electron that will look for a hole to link. Diodes are made of P-type and N-type materials. Here is an example of how the holes flow to the N-type material and the electrons flow to the P-type material. When this comes to an equilibrium, it will form a depletion region on the middle, which also will form a potential barrier, which will prevent the holes and electrons to flow over the diode. In order to conduct electricity, the electrons and the holes will need a current that flows in the direction from anode to cathode to overcome the depletion region. Laser diode. A laser diode, DL, is a semiconductor device similar to a LED, which stands for light emitting diode, but which emits laser light under the right conditions. It has an additional region, the intrinsic region. We can see it here. That's why it is a pin diode. This region, also called junction, is polished to a mirror-like finish. The N and T regions of the diode are made of materials that emit photons as electrons and holes recombine. These photons enters the intrinsic region and bounce due to the reflection from the glass finish, eventually leading to the collimation and the exit of a beam. If LEDs are two pin diodes, what makes laser diodes different from LEDs? In the case of LEDs, photons go out in all directions. In lasers, they go out in the same direction or with spatial coherence, forming a beam of light. On the other hand, the laser only allows the output of light waves with the same wavelength, and in phase or for maximum intensity. The color of the beam will depend on the specific wavelength that the intrinsic section of the diode allows to cross, which varies according to the material with which the diode is made. Color can range from ultraviolet from infrared.
Our second diode is the photodiode. It's a semiconductor of the PN type. which is sensitive when exposed to a direct source of visible or infrared light. It could be considered that a photodiode is a combination of a common diode and a photoresistor or LDR. And just like the common diode, it has its polarization. In a photodiode, the current through depends on the light energy applied to the PN junction. It operates through the reverse bias. The diode is constructed in such a way that when light strikes the junction, it is different to break. The electron wall bursts and generates electrons, which increase the reverse leakage current. Operation. For a correct operation, this diode is reverse biased, allowing the flow of the current in reverse direction. The photodiodes have a lens that allows them to concentrate the light incident on them. Thanks to this, when the incident light is of sufficient energy, it can move an electron, generating a continuous movement on other electrons, and allowing the creating of possibility charged holes. Therefore, the greater the intensity of the light hitting the photodiode, the greater the current flowing. There we can see a picture that reveals the structure of a photodiode. General information. In general information, we have characteristics and type of photodiode. In characteristics, we have that the main characteristic is the manufacturing material. Generally, this is the usually silicon, as it allows to be sensitive to light. There's also germanium, which makes it sensitive to infrared light. Lead sulfide, indium, gallium, and arsenic can also be used as an option. In types of photodiode, there are two types of photodiodes, pin photodiode and avalanche photodiode. Pin photodiode, one of the most common semiconductor, is that allows the modification of the intrinsic layer to optimize quantum efficiency and frequency range. An avalanche photodiode is very similar to the common photodiode, but the advantage is that it allows working with higher and normal reverse voltage. This diode is normally used when they receive power that can be limited since the responsivity is higher than photodiodes. Its use is not recommended in projects in which signals are used because it introduces noise to the circuit. Here we have two types of photodiode. Photodiode PPW34, which is the type PIN, and it has the next characteristic. Their dimensions are LWH is 5.4 and 4.3 plus 3.2. Radiation sensitive area is 7.5 millimeters. It has fast response times and it has an average sensitive angle. And this is the datasheet which is presented in the left picture. And the right picture represents an avalanche type photodiode, and its reference is TDFD 4300F. So this is the pin type photodiode receiver. It is manufactured by silicon. The peak sensitive wavelength is 95 nanometers typically. It has high sensitive to infrared spectrum with filters to block visible light. It has a spectral range 70 nanometers to 1070 nanometers. The max power dissipation is 215 milliwatts. inverse and direct current by 115 power amperes. And finally, we have our bibliography. And this is all.